So 7 pi over 6. 7 pi over 6. Let's convert it to our degrees. 7 pi over 6 times 180 over pi, cancels 30, is 210 degrees. Okay, so if we're looking for the cosine of 7 pi over 6, that means we can find the cosine of 210. It will give us the same answer. So now 210, we know we need to find our reference angle. So let's draw it out. Where does 210 fall on our coordinate plane? 210 falls 0, 90, 180, 270 in quadrant 3. So let's use a different color. Right, so that is 210. So my reference angle is going to be this little angle in here. How do I find the measure of that? I take 210 and I subtract 180 to see how much extra I've traveled. And that's equal to 30 degrees. So my reference angle here is 30 degrees. That means we can find an exact value. Okay, so cosine of 210 is equal to cosine of 30. But remember, we need to find the sine based off of all students take calc. So in this quadrant, in quadrant 3, cosine is negative. So cosine of 210 is equal to negative cosine of 30. Okay, so now from here, we can use our reference triangles, right? We know we have the 30, 60, 90 right triangle, whose sides have 1, radical 3, and 2. Cosine of 30 is my adjacent over my hypotenuse. So if cosine of 30 is equal to radical 3 over 2, then cosine of 7 pi over 6 is equal to negative 3 over 2. Okay, exact value. So now, what about sine? Well, I'm going to ask you to pause the video and give it a try. Okay? When you're done, unpause the video and check your work. So sine of 7 pi over 6. That's equal to the sine of 210. Now, we've already found the reference angle of 30, but in this quadrant, sine is also negative because tangent's the only thing positive. So sine of 210 is equal to negative sine of 30. Looking at my reference triangle over here, sine is equal to opposite over hypotenuse. So negative 1/2. So what's my final answer? Well, sine of 7 pi over 6 is equal to negative 1/2. Done. Okay, so it all comes back to being really, really good at working with our degrees, because if you convert back and forth, we can find exact values the same exact way. Okay, so let's try tangent this time. Find the exact value of tangent of negative pi over 3. Well, tangent, we know, can be found using opposite over adjacent, but first we have to find the reference triangle. So, negative pi over 3, we convert. We cancel. This is equal to a negative 60 degrees. So the drawing of this angle, remember negative direction is swinging down, is that direction. It's negative 60 degrees. Now, remember our reference angle is the positive measure of the angle between the x-axis and our terminal side. So even though this has a negative 60-degree angle measurement because of the direction, the reference angle is just equal to the positive 60. Okay, so that means tangent of negative pi over 3 is equal to the tangent of negative 60 degrees. And that is equal to, well, all students take calc, negative, because cosine is the only thing positive in this quadrant, tangent of its reference angle. Okay, so draw out my triangle. We have 30, 60. Opposite is radical 3, 1, and 2. Tangent is my opposite over my adjacent. So if I'm looking at my 60 degrees, that's equal to negative radical 3 over my adjacent, which is 1. So fully simplified, tangent of negative pi over 3 is equal to negative radical 3. Okay. Now, these are, again, the exact values, meaning we have radicals in their exact form, simplified. We don't have decimals that go on forever, never, never. But if you wanted to check these on your calculators, you can. Okay? If you take a look at your screen, right, above the 7, 2 spaces, there's a sine button, a cosine button, and a tangent button. Those buttons will help you calculate the sine, cosine, and tangent approximately. It'll give you an approximate decimal. Now, the one thing you have to make sure you check, your calculator, when you press the mode button, 1, 2, 3, 4 rows down, you'll see radian and degree. If you are working in radian measure, aka anything with pi, you want to make sure that this is highlighted. Okay? And then you can type in exactly what you see and it will give you an approximate decimal. If you are in degrees, you want to see this one highlighted, which you can get by scrolling over and pressing enter. Okay? You want to make sure you're in the right. The calculator will give you 2 different values for radian measure and degree measure if you type in the same exact thing. Okay, for example, let's say we wanted to check our work here. We want to find out what, tangent of negative pi over 3 is. Well, if my calculator is in radian mode, tangent of negative pi over 3 is equal to negative 1.73205, and that's in radian mode. If my calculator is in degree mode, that exact same thing will be equal to negative 0.1827, ... But if we take a look at this exact value, negative radical 3 is equal to negative 1.732. So it's clear that this is the correct answer. So you want to make sure you are in the correct mode. Okay, that only works for degrees. So if you wanted to find the tangent of 210, which we said was the same, you would want to be in degree mode and then type in the same thing. So tangent of 210. Oh, this is not 210. Sorry. Tangent of 60 would be for this one. But you get the idea. Okay. So we're going to continue. The last thing we have is an application. Other than finding all the trig functions, we can also use radians to help us find measurements on a circle. So to do this, we need to talk about what a central angle is, and what an intercepted arc is, and look at this formula. So a central angle is an angle with the vertex at the center of the circle. So if we're in the middle of the circle, this would be considered a central angle because it has the origin as its vertex. The place where it intersects the circle creates an arc. This is called my intercepted arc. So if I know the measure of the central angle, if I know the radius, I can find the measure of the intercepted arc using this formula, okay? S stands for the length of the intercepted arc. Theta stands for the measure of the central angle, but it must be in radians. And R stands for the radius measure. Now, you can be given any 2 out of the 3 and solve for the other one. That's fine. We're really just going to practice finding the length of the intercepted arc. But again, please make sure you are in radians when you do this. If you are given an angle in degrees, it must be converted. So we're taking a look at 2 problems, page 848, numbers 26 and 32. Find the length of each arc. Round your answer to the nearest tenth. Okay, so if we are looking for the length of an arc, that means we're using the formula S equals theta times R. Well, in this question, what is my S? Well, my S is that T value. That's what I'm trying to find. My theta is my angle measurement, in this case pi over 3, in radians. Is this in radians? Yes, so I'm good. My R is equal to 3 centimeters. So I can directly plug into this formula pi over 3 times 3 centimeters. These 3's canceled. I get pi centimeters. Now we know pi centimeters needs to be converted to a decimal. 3.14 rounds to 3.1 centimeters. Okay, so T is equal to 3.1 centimeters. Now let's take a look at the second one. In the second one, they give us a negative angle measurement of negative 285 degrees. And they want us to find the length of the arc on the outside, the major arc, this one right here. Okay, because that is the one that corresponds with this angle. Okay, so what's the first thing we have to do? Well, we have to make sure my angle measurement is in terms of degrees, in terms of radians. So we have a negative 285. We must convert it by multiplying pi over 180. So to do that, 285 over 180 reduces down to 19. So negative 19 pi over 12 is my theta. So I go to the formula. S equals theta times R. Negative 19 pi over 12 times 150. Now, the one thing you have to remember is that angle measurements can be negative because of direction, but length cannot. So when we find this, we actually want the positive value of this. So we don't need the negative sign. Again, because we're looking at a length that cannot be negative. Now, when you type this all into your calculator, you get 746.1, and the unit here is feet. Okay? So again, we want it to be positive because length is always positive. Angle measurements can be negative because of their direction. Okay, so what I'm going to ask for you to do, you're going to submit the exit ticket, which is those 3 numbers right there. They are multiple choice, so please make sure you show work. And then these are the practice problems that I'm going to ask you to try on your own, which I will be posting the answers to shortly.